Okay, so in this video, we're going to move on to butane. And so hopefully you've thought about this problem and what the potential metabolism pathways would be. And so for butane, I'm going to start off by pointing out a reaction we haven't really been talking about, which is ester hydrolysis. Remember how we said a couple videos back, we were talking about how phase 1 reactions can be oxidation, reduction, or hydrolysis. And so ester hydrolysis goes into that third category. But don't forget that so far, all of the reactions in this box for phase 1 were under oxidation. But right now, we're just going to visit hydrolysis, which you should know is a type of phase 1 reaction. So hydrolysis, whenever you see an ester functional group, your mind should automatically think of hydrolysis. And right after that, you should automatically think this is a type of phase 1 metabolism reaction. So when you see an ester, which looks like this, carbonyl with an OR group, you should automatically think hydrolysis, and then this is a phase 1 reaction. So again, ester functional group is this functional group right here, where I see a carbonyl directly bonded to an oxygen, and that oxygen is then bound to an R group or an alkyl group. So that's the same as this carbon, oxygen, directly bonded to an oxygen, and then an R group or an alkyl group. So be able to recognize esters quickly. So esters can undergo hydrolysis. What is hydrolysis? Well, you're going to cleave. Undergoing ester hydrolysis means that I'm going to cleave this bond right here, right? So I'm going to cleave this bond right here between the carbon and the oxygen. I'm going to cleave that bond. And what's going to end up happening is that the carbon side, so here I'm going to get an OH, okay? And then on the other side, I'm going to get an alcohol or hydrogen. Okay, so on this side, you're going to see an OH, and on this side, you're going to see a hydrogen. So how would I draw out this ester hydrolysis? Well, everything else would stay the same. Okay, so I have this NH2, and now what matters is that this carbon, okay, this carbonyl now has an OH added to it. Okay, so this part is new, this OH. And then the other side, the part that was cleaved off, had started with this oxygen, and then it had this whole entire group attached to it. Okay, and so I'm just going to put R groups there for now to signify these alkyl chains. But what gets added on here is a hydrogen. Okay, so what's new is that this carbonyl got an OH, and this oxygen over here got a hydrogen. So this is ester hydrolysis, like the whole molecule cleaved right down that bond for ester hydrolysis. Okay, so just when you see an ester, think hydrolysis, think phase 1. That's really common phase 1 metabolism reaction that you'll encounter on a lot of these molecules. Now I also want to talk about N-acetylation. So N-acetylation is a phase 2 conjugation reaction that can occur whenever you have a nitrogen. Okay, so it's whenever you have a nitrogen that, so for example, when you have an aromatic amine, or when you have an NH-NH2 group. All right, and so I'm going to add that to this list that we've been adding notes to. So for N-acetylation, which is a phase 2 reaction, acetylation, that can occur whenever you have a aromatic amine. It can also occur whenever you have an R and NH2 group. Okay, and then if you look at your lecture notes, that will have a specific name, right? So when you see these groups, you can start to think that you could have acetylation. And so I wanted to show you where this would be in your lecture notes. So in your lecture notes, you should see N-acetylation, okay? So you should see that under phase 2 reactions, and then you'll see N-acetylation reactions. And so what you'll see is when you have like this aromatic NH2 group, or when you have hydrazine, which is NH-NH2, or hydrazide, CONH-NH2. So these are from Dr. Luo's lecture notes. This is when N-acetylation reactions would occur. So again, an aromatic amine, hydrazine, and hydrazide, NH2, NH-NH2, CONH-NH2. Okay, so going back to our list, we know here with butadiene that the reason why we can undergo N-acetylation is because we have an aromatic amine. Okay, so I see this benzene ring directly bonded to an NH2, so I think N-acetylation. So in that case, we're going straight to a phase 2 reaction. Remember how I told you phase 1 doesn't always have to come before phase 2, even though a lot of the times that is the case. In this case, we already have an aromatic ring attached to an NH2, so we can go straight to a phase 2 reaction. So I'm going to erase this since we're already done with this part of the metabolism pathway, but this is kind of one of the metabolism reactions that you can easily forget about. So try to keep this one in mind. So here, I'm going to go ahead and draw this out. I'm going to have the addition of an acetyl group, because what is this reaction called? It's called N-acetylation. So to my nitrogen, I'm actually going to add a acetyl group, and an acetyl group is just a carbonyl group, so a C double bonded to an oxygen attached to a methyl group. So this group right here that I'm highlighting is the acetyl group that got it added on to my nitrogen. And if you notice that in the process I lost one of my hydrogens because there's only one hydrogen here, and then I've added this acetyl group here. So that acetyl group is what makes this N-acetylation, right? So my acetyl group, if you want to see a general structure for an acetyl group looks like this. So it's a C double bonded to an oxygen along with a CH3 methyl group. So whenever I see a carbonyl right next to a methyl group, I think this is an acetyl group, and that's what's being added here. So we're going to name this phase 2 acetylation. So that is phase 2 acetylation. Specifically, it is N-acetylation, and the reason why we could do it is because there was an aromatic amine.